Have you ever wondered why a moon over 1 billion kilometers away is capturing the hearts and minds of scientists around the globe? Well, grab a seat, or maybe float in zero gravity with me, because we're about to embark on an incredible journey to Saturn's largest moon, Titan. You see, Titan isn't just any moon. It's a world unto itself, cloaked in mystery and layers of thick, hazy atmosphere. But why are scientists so obsessed with it now? What's changed? Let's dive in and find out. First off, Titan is enormous. When I say big, I mean it's the second largest moon in our entire solar system. It's even bigger than the planet Mercury. But size isn't everything, right? What really makes Titan stand out is its atmosphere. It's the only moon we know of that has a dense atmosphere, one that's even thicker than Earth's. Imagine that. A moon with an atmosphere denser than our own planets. But wait, there's more. Titan's atmosphere is primarily nitrogen, just like Earth's. However, it has a smattering of methane and other organic compounds that make things really interesting. And when I say interesting, I mean mind-blowingly fascinating. Because these components could be the building blocks of life, or at least clues to how life might arise in the most unexpected places. Now you might be thinking, okay, a thick atmosphere and some organic molecules. Cool, but why the obsession now? Great question. Let's rewind a bit. Back in 2005, the Huygens probe, part of the Cassini-Huygens mission, descended through Titan's murky skies and touched down on its surface. It was the first time we'd ever landed something on a world so far away. The images and data sent back were nothing short of astounding. Rivers, lakes, and seas, but not of water. Oh no. Titan's liquids are composed of methane and ethane. Can you imagine standing on the shore of a methane lake under an orange sky? Wild, isn't it? But here's where things get even juicier. Recent studies have suggested that Titan's subsurface may harbor a vast ocean of liquid water. Yes, water. Beneath that icy crust lies the potential for an environment where life as we know it could, in theory, exist. Scientists are buzzing with excitement because where there's water, there might be life. And speaking of life, Titan's surface is rich with complex organic molecules, those essential ingredients for life. The interactions between sunlight and methane in its atmosphere create a sort of organic smog, which then settles onto the surface. It's like a continuous drizzle of life's building blocks, just waiting to be pieced together. But it's not just about potential life. Titan offers a unique opportunity to understand our own planet better. Earth's early atmosphere might have been very similar to Titan's current one. By studying Titan, we could unlock secrets about how life began here on Earth billions of years ago. It's like having a time machine, but instead of going back in time, we're looking outward into space. Now fast forward to today, and the buzz around Titan is reaching new heights. NASA has announced an ambitious mission called Dragonfly. Set to launch in 2027, Dragonfly is a drone-like rotorcraft designed to fly through Titan's dense atmosphere and explore multiple locations hundreds of kilometers apart. Imagine a quadcopter, but on an alien moon. How cool is that? Dragonfly will investigate the moon's habitability, studying its atmosphere, surface, and potential subsurface ocean. It will search for chemical processes that could be similar to those that led to life on Earth. The mission promises to revolutionize our understanding of this enigmatic moon. But here's the catch, or the thrill, depending on how you look at it. Titan is a tough nut to crack. Its surface temperatures hover around -179 degrees Celsius. That's about -290 degrees Fahrenheit. Brr! At such frigid temperatures, water ice is as hard as rock, and methane exists in liquid form. It's an environment that's both alien and intriguing. Yet, these extreme conditions are precisely why scientists are obsessed with Titan. It challenges our understanding of where and how life can exist. It pushes the boundaries of our technology and our imagination. And let's be honest, who doesn't love a good challenge? But there's another layer to this obsession. Titan's weather and surface processes are eerily similar to Earth's, despite being in such a different environment. It has seasons, rain, and even surface erosion. The methane cycle on Titan mirrors Earth's water cycle. Clouds form, rain falls, rivers flow, and lakes fill up, all with liquid methane and ethane. It's like a twisted mirror image of our own planet. This similarity provides a natural laboratory for scientists to study meteorology and geology in conditions vastly different from those on Earth. By comparing and contrasting, we can learn more about the fundamental processes that shape planetary bodies. Now imagine piloting Dragonfly over Titan's dunes of frozen hydrocarbons, soaring above methane lakes, and landing on varied terrains to sample and analyze. Each discovery could rewrite textbooks and open new chapters in planetary science. The possibilities are endless, and the anticipation is palpable. But let's not forget the human element here. Space exploration isn't just about data and discoveries, it's about inspiring wonder and curiosity. Titan captures our imagination because it represents the unknown, the next frontier. It's a place where science fiction edges closer to reality. And speaking of imagination, let's pause for a moment. If you could ask one question about Titan, what would it be? Would you wonder about the possibilities of life? Or perhaps you're curious about what a sunrise looks like through its dense atmosphere. Feel free to share your thoughts. After all, space exploration is a collective human endeavor, and your curiosity fuels the journey just as much as any rocket. Now, back to our adventure. One of the most exciting aspects of studying Titan is the potential to find life forms that are entirely different from anything on Earth. Life that might use methane instead of water as a solvent, or that thrives in temperatures that would freeze any Earth-based organism solid. It's a radical idea, but one that scientists are seriously considering. But of course, we have to be cautious. While the possibilities are thrilling, we must remember that as of now, there's no evidence of life on Titan. It's a canvas of potential, but we need to approach it with scientific rigor and an open mind. The obsession isn't just about finding life, it's about understanding the possibilities and expanding our knowledge of the universe. And here's something to ponder. By studying places like Titan, we're also preparing ourselves for future explorations farther into the cosmos. Each mission, each discovery acts as a stepping stone into the vast expanse of space. Who knows where Titan might lead us next? As we near the end of our journey today, let's reflect on why Titan has become such a focal point for scientists. It's a combination of its unique environment, the tantalizing hints at prebiotic chemistry, and the technological advancements that now make exploring such distant worlds possible. Titan embodies the essence of exploration, a mix of curiosity, challenge, and the pursuit of knowledge. So, what's the takeaway? Scientists are obsessed with Titan not just because of what it is, but because of what it could teach us, about our own planet, about the potential for life elsewhere, and about the fundamental workings of the universe. Now, I have a question for you. Does knowing all this make you as excited about Titan as the scientists are? Maybe it sparks a newfound interest in the moons and planets that share our solar system. Or perhaps it ignites a curiosity about the broader universe. If you're as fascinated as I am, why not join the conversation? Share your thoughts, ask questions, and let's keep exploring together. After all, the universe is vast, and there's so much more to discover. Thank you for joining me on this voyage to Titan. Until next time, keep looking up, stay curious, and remember, the next big discovery could be just around the cosmic corner.